Bianca here. So today we're going to be talking about our special right triangles. So there are two different types, and the first one we're going to be talking about is our 45, 45, 90 triangle. So 45, 45, 90. So if we have a triangle that's a 45, 45, 90, I'm just going to sketch that out over here. Here's our 90-degree angle. And we know that these two angles here are going to be 45 degrees and 45 degrees. So we essentially here have an isosceles right triangle because two of the angles are the same, which means two of the side lengths have to be the same as well. So we do put labels on the sides of these triangles. And our legs, we're just going to label as an L, L for leg. And we know that they have to be the same since we have an isosceles right triangle. So how do you get the hypotenuse then? So basically, if you take this leg and you multiply it by rad 2, so I'm going to label this as L rad 2, that would be the length of that hypotenuse right there. Okay, so that's the first special right triangle that you have. The second one that we have is called a 30, 60, 90 triangle. And I'm going to sketch that out over here. So here we go, triangle. And we have our 90-degree angle, and then we're going to have 30 degrees and 60 degrees. So it doesn't actually matter where you place them. I'm going to put the 30 degrees here and the 60 degrees here, but they can be in any of the angle sections there. So we need the lengths of the sides, right? So I always start with the smallest angle. The smallest angle there is 30 degrees. So I say, okay, opposite the smallest angle has to be the smallest side length. So opposite of 30 degrees is this side right here. So I'm going to label that with an S. Okay. The hypotenuse is always going to be double the smallest side. So I'm going to name that as 2S. And then opposite the 60-degree angle, I'm going to label that as S rad 3. So basically, if you take that smallest side length and you multiply it by rad 3, you would get the longer of the legs. Now obviously the triangle is not drawn to scale, and that's okay, right? We're just talking about the ratios of the side lengths. All right, so let's go on and do some examples with them. So we're going to start off with these two examples, super simple to begin with, and then we'll get into a little bit more challenging ones. Basically, we're looking for the missing side lengths of the triangle. Now in this case, you're both missing the hypotenuse. So if we look at the very first triangle here, right? Remember, we noticed that this is a 45, 45, 90 triangle. So that's our first special type of right triangle. So I'm going to put the labels on the triangle that we used in the first example. So remember, the legs are the same, and they are here, right? 1 and 1. And I'm going to label that as L. So we know L and L, which means our hypotenuse here is L rad 2. Well, think about what you have. You have L is equal to 1. Well, if L is equal to 1, I can go ahead and just substitute that in here. So instead of L, just replace L with 1. So here you have 1 rad 2, or just rad 2, obviously, in this case. So the length of that hypotenuse there is rad 2. Let's look at the second one here. Noticing that this top angle here is 45. Now, even if you don't have the bottom angle, we know that it has to be 45 as well because, one, looking at the side lengths, those legs, they're the same. So we know we have our isosceles right triangle, but also if you were to solve for that missing angle, remember 180 degrees inside of a triangle, subtract the 90 and subtract the 45, you're left with 45 degrees. So you can just kind of fill that in if you need. Now, our 45, 45, 90 triangle, remember the side lengths are in ratio of LL and then L rad 2. So we always circle what we have. Now, in this case, we have L is 3. Well, if L is 3, just substitute that in here, right? 3 rad 2. So 3 rad 2 would be the length of that hypotenuse. All right, so this time we're solving for the hypotenuse again, but notice what we have for our legs. Now, the legs are the same, right? So we know automatically, since they're the same, it's an isosceles right triangle, which means that the angles here are 45 degrees. So we know that's our 45, 45, 90 triangle. So remember, labels on the side lengths, we've got L, L, L rad 2. Now I always circle what we have. We have L is equal to 9 rad 2. Now we want L rad 2. I want L rad 2, I need to substitute in what L is. Now L we know is 9 rad 2, so I'm going to plug that in here. 9 rad 2, but don't forget to bring down that other rad 2. So multiplying that out, we know rad 2 times rad 2 is just 2. So we've got 9 times 2, which is 18. And 18 is the length of that hypotenuse. Okay, so notice how I'm orienting the triangles differently in each case so that you can kind of see, it doesn't matter what way the triangle's facing. We're still finding the side lengths. Now in this case, we are looking for the legs. We know that it's still an isosceles right triangle because notice the legs are both x and x. So we know that this has to be a 45, 45, 90 triangle. So I'm going to go ahead and just label my side lengths as I usually do. LL, L rad 2. And this time we have the hypotenuse. We haven't done one where you have the hypotenuse, right? So remember, I circle what I have. I have 12 is equal to L rad 2. So I'm going to write that here. 12 equals L rad 2. And essentially, I'm solving for L, or the leg. So if I want L by itself here, I have to go ahead and get rid of that radical 2. So I'm going to divide by rad 2 on both sides. Now we know that obviously that's going to go away because when you divide it, it's equal to 1. So we have 12 over rad 2 is equal to L. Now that's not allowed, right? You can't have a radical in the denominator, so we do have to rationalize. So I'm going to multiply by rad 2 over rad 2. Now when you do that, we've got 12 rad 2 all over 2 in the denominator, and that's equal to your leg's length, but remember, you can still simplify. We know 12 divided by 2 is 6, so 6 rad 2 is equal to that leg's length. So that means that here, your x value is 6 rad 2. So both of your legs are equal to 6 rad 2. Okay, so for this one, notice how I've changed the angles. We now have a 30, 60, 90 triangle, so that's a second special right triangle. So we're going to put in the side length labels. So remember, opposite the 30 degrees, or the smallest angle is the smallest side, so we label that, remember opposite, draw a dotted line across, is S. We know that the hypotenuse is always double the smallest, so 2S, and then opposite the 60 degree is S rad 3. So we always start by circling what we have. We have 15. 15 is the S rad 3 side. So I'm going to go ahead and write that out. 15, or set that equation equal to S. Here we go, rad 3. So if we're solving for S here, we have to obviously isolate. So we're going to divide by that rad 3 since it was connected by multiplication in the first place. We know S is equal to 15 over rad 3, but remember we do have to rationalize. We're not allowed to leave a radical in the denominator, so we're going to multiply by rad 3 over rad 3. Now when we multiply straight across, we have 15 rad 3 all over 3, and that's equal to S, but remember you can simplify that. So 15 divided by 3 is 5, rad 3 is equal to S. So the side length S up here, right, opposite the smallest angle, is 5 rad 3. That's what this x value is equal to. Now I need this hypotenuse length of y, and y is equal to 2s. Well, that means I need to do 2 times 5 rad 3. Well, 2 times 5 rad 3, remember you're really just multiplying outside times outside, so 2 times 5 is 10. So we have 10 rad 3 here, and that's the length of your hypotenuse. Okay, so we have another 30, 60, 90 triangle. Remember, opposite the 30 degrees is the smallest side length, which is S. Opposite the hypotenuse, notice where it's located, it's actually on the floor here. That's 2S, and then opposite the 60 is S rad 3. Once again, circling what you know, and you know 12 is equal to S rad 3. So I'm going to do that over here. Solving for S, we're dividing by that rad 3. S is equal to 12 over rad 3. But remember, you do have to rationalize. So you're multiplying by rad 3 over rad 3. And when you multiply across, you've got 12 rad 3 over 3. And that's equal to your side length. But remember, one more step, you do have to simplify. We have 4 rad 3. And that's equal to your side length S. So S over here is 4 rad 3. So that's what X is equal to. The last part is you need the hypotenuse, and the hypotenuse, remember, is double or 2 times S. So we really want 2 times 4 rad 3, and outside times outside, 2 times 4 is 8. So 8 rad 3 would be the length of that hypotenuse there, and that's what Y is equivalent to. All right, so now we're going to do a couple of problems where you have multiple triangles kind of connected. And notice that we're solving for X in this triangle over here, but we're only given one of the side lengths in this triangle here. So this is where we need to begin. We know it's a 45, 45, 90 triangle, so going back to the first special type of right triangle, and we're going to label the side lengths. So the side lengths, remember, are LL, and then L rad 2 for your hypotenuse here. Now that's what you know. So that's where you have to begin. I'm going to set up my equation. 10 is equal to L rad 2, solving for L, dividing by rad 2. We know 10 over rad 2 is equal to L, and then we have to rationalize. 10 rad 2 all over 2 is equal to L, but in reality we know we have to simplify. We've got 5 rad 2 is equal to L. So this part here is 5 rad 2, but also this part here is 5 rad 2 also. So now we are making our way to the second triangle that's here up at the top. Notice that we would have the hypotenuse of that triangle. That triangle is also a 45, 45, 90 triangle, so we're going to label the side lengths accordingly. L, L. Now notice your hypotenuse is no longer L. It's now L rad 2. And you have that length there. Okay, I'm going to set up the equation. L rad 2 is equal to 5 rad 2. So you're really just looking for L, and we know that L obviously is in the same location as the 5. But also if you wanted to do it algebraically, you're dividing out the rad 2. So L is equal to 5. So we know that the lengths of these sides of the triangles here are 5 and 5. All right, here's the last one that we're going to do. So you can kind of use this as a challenge for yourself. You notice that you have a 30, 60, 90 triangle here for both of them. And the only value that you actually have is this hypotenuse up here. So that's the triangle we have to begin with. So remember, opposite the 30-degree angle, and the 30-degree angle has to be this missing angle right here. So I'm just going to type that in there or put that in there. Opposite 30 is S. Opposite the hypotenuse is 2S, and we know that this is S rad 3. I don't really need to put the label there just yet. I know that I have 9 is equal to 2S. Okay, so 9 equals 2S. I need S, so I'm dividing by 2, so S is equal to 9/2. Now remember, this was S rad 3. So I really need, if this is S, 9 over 2 rad 3. So 9 rad 3 over 2. So that's this label right here. So I'm going to go ahead and put that in there. Let's use different colors so it kind of stands out. 9 rad 3 all over 2. Now I'm making my way to that second triangle there, but I do have to put new labels. So opposite the 30-degree, which is here, is S. And that's what we're going to be looking for, obviously, because that's where the X is located. Opposite the 90, which is your hypotenuse, is 2S. But notice you had a label of S rad 3 there. It's not that same label anymore because now we're in a different triangle. So we would put 2S. And 2S is equal to that radical. So 2S is equal to 9 rad 3 over 2. So we have to solve for S. We're going to divide by 2. And here you notice you have a complex fraction. Well, how do you solve a complex fraction? You keep change flip. So you've got 9 rad 3 over 2. Changing this to multiplication and flipping that upside down, it's really 2 over 1, which becomes 1 over 2. And that's equal to the side length there. So we're going to multiply straight across. 9 rad 3 all over 4, and that's equal to your side length, which is this piece right here. So 9 rad 3 over 4 is your x value, or the length of that leg. All right, so that's it for today on special right triangles. And I'll give you a worksheet on a couple of different examples that you can kind of go through.